So number 48, we've got a natural log function, and that means that t cannot be negative. T could be bigger than or equal to 0. And I've already graphed this one and realized that the calculator doesn't do a great job, so I just want to point out something first of all. So when t becomes a 0, the natural log function, so the natural log function itself looks like this, and as the t is getting smaller and smaller, that means that the natural log function is going to negative infinity. And since in this problem, that's saying what x is, that means x is going to negative infinity. I know that looks a little bit confusing because I just drew that y is going to negative infinity, but this graph that I'm erasing right now is actually for just y equals the natural log of x. This one is saying x equals the natural log. So the natural log goes to negative infinity, that means x goes to negative infinity. And while it's doing that, since the t is becoming a 0, sorry, I didn't know I had the eraser there. Since t is becoming a 0, that means y is becoming, if you plug in 0, y is becoming 3. So even before I graph it, I know that the y value will become a 3 as the x is going to negative infinity. So that means that it goes something like this. Okay, I want to point that out because the graphing calculator makes a mistake, which is part of the reason that we're doing this one, so you don't get tricked by the graphing calculator. So let's go over to the graphing calculator. Here is the function, x equals natural log of t, y is the 5t plus 3. For the window, just don't put any negatives for t. And then I'm going to change this to be like negative 5 to 5, and y value is negative 5 to 10. And then look at the graph, and you see how the graph stopped? So it really should have, from here, kept going and going. I think perhaps I could try to fix that by going to the window and then changing the t step so that it draws it more accurately. So if I change that to a 0.01, then, well, it stretched it out a little bit farther, but it's really supposed to flatten out. Okay, so the graph is supposed to cross the x-axis. It looks like approximately at 8, and otherwise it basically looks like the e function. All right, back to the drawing board. So I think I'm just going to regraph this one. So it looked like it was crossing the y-axis at 8, and then it should basically look like the e function. And then it was leveling off where y is 3. Okay, that's the graphing part. The other part is eliminate the parameter. So with this first equation, I could eliminate the natural log by exponentiating both sides. So I would get e to the x equals e to the ln of t. And then, of course, those two cancel, and we just get e to the x is equal to t. And then take that and substitute it into the second equation. So then we get y equals 5, and then replace t with e to the x, and then plus 3. Oh, now the graph makes sense to me. Because first of all, it's the e function, so that means that it needs to look like this. Then if you have x equal to 0, you would have 5 e to the 0 plus 3, and then that would be 5 plus 3 equals 8. So my suspicions about this 8 was correct. And as the x goes in the negative direction, then the e part will disappear and you're left with just the 3. So in y equals 5 e to the x plus 3 form, the graph makes more sense to me.